on rational and radical equations. So a rational equation is basically anything involving a fraction. When I solve these, and kind of thinking through this whole thing, we need to be very careful with our answers. It is possible to get answers that don't really work. So to prevent that, you have one of two things. You can either check your answer every time, every problem, which isn't hard. You have a calculator, you can plug it back in. On these rational ones, a lot of times I try to make a note to myself about what numbers would not work. If you have a fraction, what cannot happen in a fraction? There is one thing that we cannot have. Think about more specifically the denominator. What's one thing we can't divide by?
0.
Yeah, we can't have a 0 on the bottom. If you try to type in 5 divided by 0 in your calculator, it tells you domain error. It's not something we can do. So when I'm looking at this, I know that no matter what answer I get, the bottom of this fraction can't be 0. Now, does 2 ever equal 0? No. Does x minus 1 ever equal 0? Yeah. When x equals what? 1. So I'm going to make myself a note. X cannot be 1. If you don't do that, it's not the end of the world, but you will need to make sure you're checking at the end, because it's possible that we might get 1 as a solution, and that really won't work. Alright, so we have different strategies we can take now. We can try to get a common denominator and make these a single fraction. But in my experience, I've taught this a time or two, people usually don't like fractions. I don't know what happened to you in your childhood, you've been traumatized, you don't like fractions now. So our gut instinct is really just to get rid of the fraction whenever we can. And that's honestly probably the easiest way to go about solving these. So if I'm looking, this fraction has a denominator of 2. So what would I have to do to get rid of that? Multiply by 2. This one has a denominator of x minus 1. So to get rid of that, we have to multiply by, okay. I'm going to rewrite this just because I need a little more space. I like to show you exactly what I'm doing here. So if I want to get rid of the 2, we can multiply by 2. But we know, if you're solving equations, whatever you do to one side, you have to do to the other, right? And I can't just multiply one term. I have to take everything on this side times 2, everything on that side times 2. So I like to write it beside every single term. So I'm going to multiply everything by 2. That gets rid of this denominator. For that, I need to multiply by x minus 1. But if I do it to 1, we have to do it to everything. That cancels this denominator. So at this point, I'm left with 2x minus 3 times x minus 1 plus, here I have a 2x times 2 equals x times 2 would be 2x times x minus 1. Now I no longer have fractions, so this is just a normal equation for us to go about solving. So we need to FOIL here. So we get 2x squared minus 2x and minus 3x would be minus 5x. Negative 3 times negative 1 is positive 3. Plus 2x times 2 is 4x. Equals 2x squared minus 2x. should I do here? Mm-hmm. If I subtract my 2x squared, those actually drop. I am going to add this x to the other side. So we have 3 equals a negative x, divided by negative 1, so x is negative 3. So now, we need to check. So you can either go back and work it all out, plug in negative 3 and verify that it works, but at the very least, if you don't take the time to check everything, you need to make sure. We said x could not be 1. So is negative 3 an okay answer? Yes. So as long as we didn't make any math errors, we should be good. Let's look at another. Can you tell me right now what x cannot equal?
5.
Good. Alright, so the first term has a denominator of x minus 5. So we have to take everything times x minus 5. Do I need to multiply by anything else? That cancels this one and this one. We have an x plus 5 times x minus 5 plus 5. So 6x, if I add that 25 over, plus 30, divide that 6, and I get x equals 5. What's wrong with that? Right, we said it can't be 5. If you try to plug that in, you get 5 divided by 0, and we can't do that. So the only answer we got was 5, and we said that would not work. So our answer here is no solution. Let's take a look at this one. This one, it's not quite as obvious what x cannot be from the beginning, because we have that x squared minus 2x. So what do you think we should do with that?
We can just factor the x out, right?
We need to factor those denominators first. BCF, that would be x times x minus 2. Not saying that we necessarily had to do that, but this will give us a much simpler problem so we're not multiplying by more stuff than we have to. Can you look at this problem and tell me everything that x cannot equal right now?
0 and 2.
X minus 2, so we can't have a 2. So plain x can't be 0, and this just has the same things. Alright, so if I'm trying to get rid of my fractions, first one has an x minus 2 on the bottom, so we take everything times x minus 2. So cancel. And these cancel. And this one has an x, just a plain x on the bottom, so we have to multiply by a plain x. And at that point, there's nothing left on the bottom. So I'm left with x times the 3x plus 2. 1 times x minus 2 equals negative 2. X plus x, that's a 3x. Quadratics we always set equal to 0, but if I add that 2 over, they actually cancel out. So at this point, what would I do?
Take 3x out.
X plus 1. So to finish, you set each of those equal to 0. And we get 0 and negative 1. But we know we have to check. So if we look back, x cannot be 2 or 0. So that means the negative 1 works, but the 0 does not. So negative 1 is the only answer here. I want you guys to try the next one on your own. So x cannot be what was the x not equal to this time?
Negative 1, 1.
So we have to multiply by both x minus 1 and x plus 1. So negative 4 times x plus 1. 4 times x minus 1 plus negative 8. I dropped an x. Okay. So I have negative 4x squared. Those drop. I'm going to add my 4 over, so equals negative 4. If we divide, we have x squared equals 1, square root, plus and minus. So everybody got to that point, x equals plus and minus 1. But we said at the beginning that x could not be either of those, so that means this is a no solution. So looks like we're doing pretty well on that type of problem. Any questions for me here? Second thing I want to look at today are problems involving radicals. when we look at this, we need to be able to get rid of the radical. In order to do that, the first step is to isolate the radical, get it by itself. So to do so, I just need to move my 2 to the other side. We have the cube root of 2x minus 4 equals 2. Then how do you get rid of a cube root?
You cube both sides.
So the cube root and cube cancel, so I have 2x minus 4 equals 2 to the third power is 8. So if I add over my 4, you get x equals 6. You do need to check your answers on these. There's several things that would make you get an answer that doesn't work. It's not really with odd roots, so like cube root, fifth root, seventh root, it won't happen, but with the even roots, we can get answers that don't really work, because we know that if you have like a square root, what happens if there's a negative under the square root? You get an imaginary number. And once we start squaring things, we lose some of those. So rather than trying to remember if this and this and this are true, check it, just check all of them. And that way you catch any mistakes, because it is possible to get answers that don't really work on these. So quickly, if I plug that back in, 2 times 6 is 12, minus 4 is 8, cube root of 8 is 2, and 2 minus 2 does in fact equal 0. So 6 is my answer. You don't have to write out your work for checking. If you do it on a calculator or in your head, that's fine. But you need to do it, because if you don't throw out an answer that doesn't work, you would lose points there. Let's try this one. So first step, we always have to have the radical by itself. And it is here. Second step, we have to get rid of it. So how do you get rid of a square root? Square both sides. The key here being both sides. So when we are multiplying, we were multiplying by the denominator and essentially distributing it to each term. But squaring doesn't work that way. I can't just square the x and square the 7. I'm squaring that entire side, which means I have to do what? What? So over here we have x minus 1. If you think about it, if we have 2 of these, x squared minus 7x and minus 7x, so minus 14x. 7 times 7 is 49. Quadratics, we always set equal to 0, so if I subtract my 1, subtract my x and add my 1. What multiplies to positive 50 adds to negative 15? So if we set those equal to 0, we get positive 10 and positive 5. We have to check. So if I plug in my 10, I get the square root, 10 minus 1 is 9. So I get 3 equals 3, which is good. If I plug in a 5, I get the square root, 5 minus 1 is 4. But we have 2 equals negative 2, and that does not work. So we have to throw out the 5, and 10 is the only solution. How are we doing with these? I'm going to stop there for today. I want to give you guys a chance to practice. So 7 through 23, EOO. I do this a lot. It means every other odd. So you do problem 7, skip 9, do 11, skip 13, do 15. So if that helps. Sometimes I confuse people. I gave you all odd problems because I want you to check yourself. The answers were in the back of the book. But when I'm giving you odd problems, I expect work. So if you just have answers and no work, you're not going to get